Hey engineers, this is Mr. Hernandez, and this week we're going to teach the robot a new trick. We're going to be putting down the pen, I'm going to stop drawing, and instead we're going to learn how to navigate a maze. So along the way, we're going to learn how to use some sensors, we're going to learn what a Boolean is, and we're going to figure out how to drive the robot when you don't have any measurements. So this is going to really test you on some new programming skills, as well as some sort of planning skills too. So let's go ahead and jump into it, take a look at the new lesson. So this is called Vex Robotics number 5, and I called it Now I Know My AB, and you'll see why in just a moment. But let's start with the new information. So the new concepts are right here. So the first bit of new information is this bump sensor. So the bump switch is a physical switch that's on the robot. All it does is detect if the robot is touching something. So if it bumps into something, if something compresses the spring on the front there, it's going to report back true, which means it's being pressed right now. And if it's not touching anything, it reports back false or 0. So true and false in computer terms also correspond to 1 or 0. But we're mostly going to use true and false from here on out. Things like this that can only be true or false, 1 or 0 and nothing in between, these are also called Booleans. So that brings us to the Boolean reporter block. This is how we're going to use sensors in our program. So the physical bump switch is interacting with the world outside, and then the Boolean reporter block is one way that we can actually get the program to pay attention to what the switch is doing outside. So these little hexagonal blocks, they correspond to different sensors, and they'll report back the true or false values, and you can use them in other blocks. Other blocks like the wait until block. This orange block has a hexagonal opening in it, and that shows you that it's a space for a Boolean reporter. This particular block, the wait until block, this will stop the program from going to the next block until it gets a true value. So this will be really useful for us as we program the robot to navigate the maze. So from here, we can jump into Vex Code VR with the link right here. And unlike before, you're just going to open the playground and switch to the maze template, not to the art canvas anymore. And you're just going to clear out any old code blocks that you still have, because we're going to start from scratch here. So in Vex Code VR, we've got the playground open, and instead of art canvas, you're going to switch to the maze. Now there's a few different mazes that you will see here. So there's the disk maze, there's the wall maze, and the dynamic wall maze. You want the regular wall maze. So this is the layout for the regular wall maze. So the robot starts down here in the green square, and we are going to be targeting a few different destinations here on this maze, and the robot's going to be driving totally autonomously. So let's go jump back into the document and let's take a look at the first actual activity. So first, there are some intro questions. You guys can read these and respond to them on your own. If you want to respond with code blocks, you can do that as well, but I don't think you need to on these two. Let's go down to program number 1. So program number 1, we're going to navigate to A on the map. And you want to do this using only the bumper switch and wait until blocks. So I'm going to really try to avoid giving you any distances here. So you're not going to know how far away anything is, and we want to try and program the robot so that it can still get to where it's going even without measurements. That's why the first question says, how far away is the first wall? Well, the answer is it doesn't matter. And we're gonna solve that problem with the bumper switch. So first real question. Where does the robot need to turn when it reaches the first wall? Well, if we look at our path here, the robot goes forward and then it needs to turn left. So this first one would be to turn left. And to translate that to code blocks, we know that that is going to be a left turn. So turn left 90 degrees, take a screenshot of that, and report that here. Okay? Now, it's all well and good for it to turn left when it reaches the first wall, But let's go backwards a little bit. How does it get to that first wall? Well, I told you that we don't know the distances, so we can't use a drive forward for block. Instead, we're going to use a just plain drive forward block. And just to check, let's watch what happens when we run this program. All right, it's pretty much what we'd expect. The robot drives forward, crashes into the wall, and here at the wall, it's still trying to drive forward. Now, let's combine the drive forward block with a wait until block. So down here, I can get a wait until. So that means it's going to start driving, and it's not going to go to the next block until it receives the value true. And what Boolean are we going to put there? Well, we're talking about the bump sensor, so we're going to be using a bump sensing or a bumper sensing Boolean right here. So what this means is it's going to drive forward until it hits something, until the sensor detects something, and then it's going to turn left. All right, so this is the first couple steps of our program. Let's see if it does what it's supposed to do. All right, so instead of crashing into the wall, it just touches the wall and then it turns. That's perfect. So that means that on our path, we've basically completed this first red arrow and we still have some more to go. So we've gone forward and then we turned left. Now, next step. What does it need to do when it hits the second wall? Well, it also needs to turn left. So that means that we can kind of just repeat that. So it's going to drive forward until it hits the next wall, and then it's going to turn left. And once it's done that, it's gone forward, it's gone to the left over here, and now it's turned, so it's facing down. And the last thing that it needs to do is just drive forward one more time. So there are 3 separate arrows there. That tells you it's going to be driving 3 separate times. So to close this out, we just need one more drive forward block. And that's our program right there. And let's see what it does. So it should go up to the first wall, then turn, then go up to the second wall and turn. And last, it's going to finish by just driving forward. And now it's on the A. So to close this out, I would take a screenshot of the completed program and add that here. And then take a screenshot showing that the robot successfully made it to its destination. Now, an interesting thing that happens is it really does try to simulate the robot driving. So you can't really tell in the top-down view, but if we switch to one of the close-up views, you can see it managed to crash into the wall and flip over. Not a big deal usually, but it does happen if you let it just keep driving into the wall. Okay, so that's the first section. So it's gone up and made its way over to the letter A. For the next one, you're going to extend it. So instead of driving and just making 2 lefts and getting to the letter A, we're going to extend it out and it's going to drive all the way to the number 2. So I'll give you guys just a hint for the first part, and I'll let you guys proceed from there. So the robot's going to go up and just like before, hits the first wall, turns left. Then it's going to go over to the side, hits the second wall. This is where the first change comes in. Instead of going left to face down towards the letter A, it needs to turn right to face up. So when it hits the second wall, it needs to turn right. Then it's going to go up to the third wall. So it's easiest to kind of count things in terms of walls because it's going to drive forward, hit a wall, and then it needs to make a decision. So I'll let you guys figure out what it needs to do when it hits that third wall and the fourth wall in order to get over to 2. So you guys will be able to do that once you write this program. You're going to have 1, 2, 3, 4, 5 different driving sections here. You need to be careful on this next step. Make sure you read the instructions because for program number 3, you just need to delete the last 2 drive and turn sections because program number 3 is going to be based on that. So you can see the blue arrows here. That's all the stuff that is recycled directly from program number 2. So if you did it correctly, you just need to erase these last 2 sections from your answer to program 2, and then you can continue on with these new red arrows to direct the robot over to the letter B. Program 3 is different from the other ones in one more important way. There is one distance that I'm going to give you. So after the robot turns the correct direction, when it hits the 3rd wall, it's going to drive forward exactly 250 millimeters. So you don't need to use the bump sensor for this one particular section. Everything else, you can do it with the bump sensor. I will also note, the point of doing this assignment is to use the bump sensor. So if you turn in your code and you're not using the bump sensor, if you're kind of, figuring it out using the drive forward for block, and you're just guessing all the distances, you will be losing points. This is not just about getting the robot to the destination, it's also about the programming journey that takes it there. And don't forget, there is one last page of questions. These are just, check your understanding of how the blocks work. So you can come down here and don't forget to answer these last 2 questions before you turn this in. All right, engineers, I hope you have fun navigating this maze, and I'm looking forward to seeing the code that you guys write.